Hello everyone and welcome to our YouTube channel, S-CUPREC Academy. S-CUPREC is simply a success-based corporation which is entitled to assist students both online and on-site in their academics. Okay, in S-CUPREC we are devoted to assist students, GC candidates, concours candidates, that is students going in for entrance examinations, and as well as university candidates and even more. Okay. More to that, in S-CUPREC, we are the best aspirants for success in excellence. Let's get straight away into today's lesson. Today's lesson is dedicated to the Faculty of Science, Departments of Biochemistry, Microbiology, Biomedical Sciences, Applied Botany and Applied Zoology, Environmental Sciences, and others, not forgetting Departments of Geology as well. Okay, the course title for this lesson is Mathematics for Biologists, and the course code is Maths 2108. Please, in a university milieu, it's always good for you to master your course title and course code for any course you're offering. Okay, the content of this chapter is simply contains indices, logarithms, and exponential functions. But we're going to move part by part. Okay, so let's begin with part 1, which is indices. It may be simple as it is. Let's begin with an introduction. So generally, the short form of writing numbers, say a times a times a times a times a times a, observe and see that we have 6 a's here. It's simply as writing that number as a raised to the power 6. Okay, so if we have something like if a has repeated itself 7 times, that means we can simply write it as a raised to the power 7 in order to reduce the length of writing. Okay, let's look at the concept of notation. Generally, any number which is written in the form a raised to the power n is said to be in index notation or per se index form. Now, what do we need to know? We need to know that n is called the power, the index, or could also be called the exponent, while a is called the base. Okay, take note of that. A is called the base. Into the laws of indices. Law 1, the multiplication index. It simply states that if we have a raised to the power m multiplied by a raised to the power n, what do? We simply need to add the powers. Since the bases are the same, we simply add the corresponding powers m and n. So it becomes a raised to the power m plus n. Okay, let's take an example to better understand that. If we have 2 raised to the power 5 multiplied by 2 raised to the power 3, so you see the bases are the same, 2, 2. So we simply add the powers. So we take 2 raised to the power 5 plus 3. Okay, take the base raised to the summation of their respective powers. So we end up with 2 raised to the power 8. Law 2, the law of division. Generally, we have a raised to the power m divided by a raised to the power n. Observe and see that as well the bases are the same. So we simply need to subtract the powers when we are dividing. So we simply have the base raised to the power the difference of the powers respectively. So let's take an example. For example, if we have 3 raised to the power 5 divided by 3 raised to the power 2, we simply have to take 3 raised to the difference of their powers, which is 5 minus 2. Okay, so we end up with 3 raised to the power 3. Law number 3, the zero law. Generally, we have a raised to the power n divided by a raised to the power n. Observe and see that the bases are the same, so we subtract the power. So we end up with a raised to the power n minus n, which is the same as a raised to the power 0. Now, this is where the zero law comes in. The zero law simply means that anything raised to the power 0 is always equal to 1. Okay, so for example, we have 3 raised to the power 2 divided by 3 raised to the power 2. We see that the bases are the same, so we subtract the powers. So we are going to end up with 3 raised to the power 2 minus 2, which is 3 raised to the power 0. And we know that the zero law says anything raised to the power 0 should always be equals to 1. Okay, so take note of the zero law. Anything raised to the power 0 should always be equals to 1. If we have 1 million raised to the power 0, it's always going to be equal to 1. Okay, I love money so well, that's why I'm saying money. If we have 100 raised to the power 0, it's equals to 1. So take note of that. Now, the law of further powers. It simply states that if we have a raised to the power m, all that to the power n, we simply multiply the powers. Okay, so for example, let's look at this sample. Let's simplify 3 raised to the power 4 raised to the power 5. We simply multiply the powers. 4 times 5. Okay, so we have 3 raised to the power 4 times 5, which is 3 raised to the power 20. Okay, that's simply the law of further powers. Now let's look at the law of negative exponents. Okay, it says that if we have a raised to the power minus m, it is simply the same as 1 divided by a raised to the power m. Okay, as well, if we instead had a raised to the power m, it's going to be equals to 1 divided by a raised to the power minus m. Take note of that. Okay, that's the law of negative exponent. So let's take a look at a sample for better understanding. Let's simplify 5 raised to the power minus 4. 5 raised to the power minus 4 will simply be the same as 1 divided by 5 raised to the power 4. Okay, that's the law of negative exponents, and so on. Let's take this other sample for better understanding. If we have 1 divided by 3 raised to the power 4, the reverse of the law, it simply becomes 3 raised to the power minus 4. Okay, well understood. Let's take a look at the law of roots. If we have a raised to the power 1 on n, it becomes equals to the nth root of a, all of that raised to the power 1. Okay, but now let's look at the general law. The general law simply states if we have a raised to the power m on n, it simply becomes equals to the nth root of a, all of that raised to the power m. I know this may sound trickish. Let's take an example so that we can better understand. Let's simplify 25 raised to the power 3 on 2. So you see that in this case, our m, the value of our m is 3 and the value of our n is 2. So, and our a here is 25. So let's follow the same approach. So 25 raised to the power 3 on 2 becomes the square root. When we have our n to be 2, it simply means we're talking about the square root. If it's 3, we're talking about the cube root. If it's 4, we're talking about the fourth root, and so on. So we have the square root. Automatically note that this is a symbol for square root. Okay, so we have the square root of 25, all of that raised to the power 3. But what is the square root of 25? The square root of 25 is the same as writing root of 5 raised to the power 2. You see, automatically these 2 cancels away with the square root sign, and it simply implies that the square root of 25 is 5. Okay, you can punch it on your calculator and it gives you the answer automatically. So we end up with 5, all of that raised to the power 3. Please always finish simplifying what is in the bracket first before you include the power. Okay, so we have 5 raised to the power 3, and that is our answer. Okay, let's also simplify 64 raised to the power 2 on 3. So 64 raised to the power 2 on 3 is the same as the cube root of 64 raised to the power 2. But what is the cube root of 64? 64 is the same as writing as 4 raised to the power 3. Automatically this 3 goes away with the cube root sign, and we end up with 4. That simply means the cube root of 64 is 4. You can also punch it on your calculator and you have the answer without stress. So we have 4 raised to the power 2, which is equals to 4. Sorry, 4 raised to the power 2, which could be equals to 4 squared, or 4 times 4, which is 16. Okay, now let's go into another phase. Let's look at equations involving powers index or exponents. Now, to solve this type of equations, we just need to take note of the following tricks as I will explain below. Okay, so the very first point is that you need to know that an equality sign simply means the expression on the left hand side is exactly the same as the expression on the right hand side. Okay, so generally, if the bases are the same, we simply need to equate the powers and solve for the unknown value. Okay, take note of this. Also, if the powers are as well the same, we can equate them and solve for the unknown value as well. This may sound trickish, but please, let's take a few exercises, sample exercises of course, for better understanding. Okay, let's look at some sample exercises. In this sample exercise, we're going to be looking for the values of x in the following expressions. So let's begin with 1. Given that we have 2 raised to the power x equals to 2 raised to the power 3, if you observe keenly, the bases here are 2 and the powers are x and 3 respectively. Okay, so since the bases are the same 2, 2, we simply equate the powers, and to that effect, our value of x is simply equals to 3 because the bases are the same. We just have to equate the powers. Example 2, given that we have 3x equals to 3 raised to the power x equals to 3 raised to the power 5. Now observe keenly and also see that the bases are the same, so we simply have to equate the powers. So this simply means that the value of x is equal to 5. Okay, now let's look at exercise 3. If we have 5 raised to the power x equals to 1, this is very trickish. You have to take note of something here. You have to take note of the zero law of indices. So you have to know that 1 can also be written as 5 raised to the power 0, because anything raised to the power 0 is always equals to 1. We're using 5 because we want the bases on both sides to be the same so that we can equate the powers. Okay, so it simply means that what? 5 raised to the power x is the same as 5 raised to the power 0, because this 5 raised to the power 0 is the same as 1, so nothing changes. Okay, so to that effect, you see that the bases are the same, so we simply equate the powers and our value of x is equals to 0. Exercise 4. Given that we have 4 raised to the power x equals to 1, the same approach, I think it was one of your past C equations, take note of this. So you have to know that 1 can also be written as 4 raised to the power 0, because we want to express it in the base form of 4 raised to the power x, okay, so that the bases should be the same. And if you see that we're going to have 4 raised to the power x plus 4 raised to the power 0, and since the bases are not the same, we can equate the powers. Okay, so we simply see that the value of x is equals to 0 because the bases are, we just equate the powers. Okay, so you see mathematics is as simple as ABC. All you need to do is to get the principles involved. Okay, we have 2 raised to the power x equals to 1 raised to the power 3 on 2. Now, first of all, we have to express 1 divided by 32. We have to express it in the base form of 2. Okay, so we have to note that 1 on 32 is the same as 1 divided by 2 raised to the power 5. 2 raised to the power 5 means 2 times 2 times 2 times 2 times 2 times 2, which is 32. Okay, and also if you look at the law of negative index, it is the same as 2 raised to the power minus 5. So you see that we have already expressed we have already expressed 1 on 32 to the base of this 2 raised to the power x. Okay, so to that effect, it simply means that our expression above can be written as 2 raised to the power x equals 2 raised to the power minus 5. And observe and see now that the bases are the same, so we can equate the powers. Okay, so simply our value of x equals 5. Okay, question 6. Given that we have 3 raised to the power x equals 1 on 8, this is still the same approach. You have to express 1 on 81 to the base form of 3. So it is the same as writing 1 divided by 3 raised to the power 4. Okay, and looking at the law of negative index, it is the same as 3 raised to the power minus 4. So to that effect, we have 3 raised to the power x equals 3 raised to the power minus 4. And observe keenly, you see that the bases are the same, so we equate the powers. And this implies our value of x equals to minus 4. Okay, if we have 10 raised to the power x equals 0.001, also we have to express 0.001 to the base of 10 as well. How can we do that? It is simple. We have to move how many units to the right to have the whole number? 1, 2, 3. So this is the same as writing 1 divided by 1000. If we move 2 units to the right, it's the same as writing that number, that whole number, divided by 100. If it's 1 unit, you divide the whole number by 10. Okay, and so on. That's the principle. So we have to know that what 0.001 is the same as writing as 1 times 10 to the power minus 3. Okay, which is the same as 10 to the power minus 3. Or you could just write it as 1 divided by 10 to the power 3, which is the same as what? If you look at the law of negative powers, it will be the same as 10 to the power minus 3. Okay, so this simply means that we have 10 raised to the power x equals 10 to the power minus 3. And if you observe keenly, you see that the bases are the same, so we equate the powers. And x equals minus 3. 8. If we have 10 raised to the power minus x equals 0.00001, observe we have how many zeros? 1, 2, 3, 4, 5. Okay, so we're going to move how many units to the right? We move 1, 2, 3, 4, 5, 6 before we get the whole number. So this is the same as writing this as we can write it as 1 times 10 to the power minus 6, or 1 divided by 10 to the power 6, or 1 divided by 1 million. Okay, which is the same as 10 to the power minus 6. So if we substitute back above, we are going to have 10 raised to the power minus x equals 10 raised to the power minus 6. Okay, so since the bases are not the same, we just equate the powers, and we have x to be equals to, okay, hold on, we have negative x, be careful, we have negative x to be equals to minus 6. Now we are looking for the value of x and not the value of minus x, so we have to divide both sides of the equation by x, and the x cancels off, and we end up with x to be equal to 6. Number 9, if we have 2 raised to the power x equals 0.25, how can we simplify this? The same approach. We move until we get the whole number. So we have to note that what 0.25 can be written as 25 divided by 100. Okay, why? Because from here we have to move 2 units, 1, 2. So since we have moved 2 units, it means we are dividing that whole number part by 100, or we're multiplying it by 10 raised to the power minus 2. Okay, since we've moved 2 times towards the right. And 25 on 100 is the same as 1 on 4. Okay. So also you have to know that 1 on 4 is the same as 1 divided by 2 times 2, which is the same as 1 divided by 2 raised to the power 2. Law of negative powers is the same as 2 raised to the power minus 2. Okay. So now you see that the bases are the same. So we have 2 raised to the power x equals 2 raised to the power minus 2. And since the bases are the same, we just equate the powers. And this gives our value of x to be minus 2. Okay. Given that we have 5 raised to the power x equals to 25, how can we find the value of x? Now you have to recall that 25 can be expressed as 5 times 5, which is 5 raised to the power 2, right? Okay, so if we resubstitute above, we are going to have 5 raised to the power x equals to 5 squared. And you automatically see that we have already expressed 25 to the base of 5. And to that effect, the bases are the same. And we simply equate the powers, and we have our value of x to be equal to 2. Okay, number 11. Given that we have 3 raised to the power x equals to 27, how can we find the value of x? It's as simple as ABC. You have to recall that 27 can be written as 3 times 3 times 3, which is 3 raised to the power 3. Okay, so resubstituting above, we have 3 raised to the power x equals to 3 raised to the power 3. The bases are the same, and since they are the same, we simply equate the powers. So that gives our value of x uniquely to be equals to 3. Very good. Number 12. Given that we have x squared equals to 3 squared. Wow, this is interesting. Now remember the second trick we said. Observe keenly and see that the powers are the same. And since the powers are the same, in this case, we just need to equate the bases. And that gives our value of x to simply be equal to 3 without stress. Okay, so the same, or if the powers are the same. Number 13. Given that we have 3x minus 1 all that raised to the power minus 1 equals to half. Now it is as simple as ABC, but looks very trickish. I'd love you to attempt this before you, to pause the video and attempt this before you continue to see the solution. It is as simple as ABC. You have to know that a half is the same as 2 raised to the power minus 1, right? From the law of negative powers. So this simply implies that 3x minus 1 all that raised to the power minus n will be the same as 2 raised to the power minus 1, which is a half. Okay, so observe keenly and see that the powers are the same on both sides of the equation, and since the powers are the same on both sides, we simply have to equate the bases. Okay, as simple as that. The powers are the same, so we just equate the bases. So this simply implies that 3x minus 1 equals to 2, and this is a linear equation. Anything that does not contain x, we send it to the right hand side, to the other side of the equation. And when something is crossing an equality sign, this is an equality sign here. If this negative one is crossing, the sign has to change to become positive. Okay, so 3x equals to 3. 2 plus 1 is 3. So at this point, to make x the subject, we have to, 3 is an obstacle, so we have to divide both sides of the equation by 3. Okay, so that's going to help us eliminate. That's going to help us to be able to make x a subject. Okay, so we divide both sides of the equation by 3, and you see that our value of x becomes equal to 1. Number 14. Given that we have 2 raised to the power x plus 3 equals to 16, how can we find the value of x? We have to begin by expressing 16 to the base of 2, or bringing 16 down to the base of 2, as we have been doing above. So generally, 16 is the same as 2 times 2 times 2 times 2, which is the same as 2 raised to the power 4. Okay, so this implies that 2 raised to the power x plus 3 will be equal to 2 raised to the power 4. Now you see that the bases are the same, and to this effect, we can now equate our powers. As simple as that. So this implies we have x plus 3 equals to 2. Sorry, x plus 3 equals to 4, and 3 is an obstacle, we send it to the other side of the equation. When something is crossing, the sign has to change. If you see it was positive, as it has crossed, it now has to become negative. Okay, so that implies that our x is simply equals to 1. Okay, in this lesson, we are midway gone. Please, if you haven't subscribed, I would love you to kindly click on the subscription button so that whenever we release a new video, you'll be notified. So at this point, we are going to dive straight in logarithms, which is part 2 of this lesson. Okay, so we are going to mainly be focused on logarithms. Okay, so we're going to be detailedly looking at the laws of logarithms. So law number 1, the law of multiplication. Generally, if we have log of a times b, it is the same as log a plus log b. As simple as that. Now let's take a sample. If we have log of 3 times 4, it should be the same as the log of 3 plus the log of 4. Okay, take note of that. Law number 2, the law of division. Generally, if we have the log of a divided by b, it should be the same as the log of a minus the log of b. Okay, please take note of that. It's as simple as ABC. Okay, so for example, if you have the log of 7 on 5, it should be the same as the log of 7 minus log of 5. Please, you can punch this on your calculator to ensure that it is homogeneous. Okay, to ensure that the left hand side equals the right hand side. Okay, let's look at the laws of logarithm. The law of powers. Okay, so if we generally have the log of a raised to the power n, it is the same as n log a. We simply bring down this power down here and we have n log a. So for example, if you have the log of 25, it is the same as the log of 5 squared. Okay, 25 is the same as 5 squared, so we simply bring down these 2. Okay, so we have 2 log 5. Okay, that's law number 3. So law number 4. Okay, generally we have the log of a base a. You see that we have the log of a to the base a. They are the same. Okay, so it simply equates to 1. So we have the log of a number to the base of that same number. The answer always equals to 1. Okay, for example, the log of 5 base 5 is equals to 1. Okay, so let's look at the relationship between logarithms and indices. So generally we have the log of a to the base of b equals to c. Then it simply implies that what b raised to the power c should be equals to a. Okay, so take note of this, please. This relationship is very, very important. So this one we have it as, we call it the log form, and this other one we call it the index form. Okay, so let's look at some soft examples to better understand these principles. Let's simplify the log of 49 base 7 equals to 2. Now observe and see that if we are applying the law exactly above, you see that 49 equals to 7 squared, and it is true, 49 equals to 49. So that's just to help you understand the application of the law above. So if we have the log of 1/4 to the base a half equals to 2. Now what do we have? You simply have what? 1/4 to be equals to a half raised to the power 2. Okay, and a half raised to the power 2 simply means you take 1 squared divided by 2 squared, which is 1 on 4. Okay, so this implies that 1 on 4 equals to 1 on 4, and that's it. Number 3, if we have the log of 1 base 5 equals to 0. Now it simply means that what 1 is equals to 5 raised to the power 0. Please follow this notation above. I'm simply using this conversion up here to convert the log form into the index form. So we have 5 raised to the power 0. Our 5 here is simply our b. Our 0 is our c, so we have b raised to the power c, which is 5 raised to the power 0, to be equals to our a, which is what? 1. Okay, so that's it. So you have to know that 5 raised to the power 0, any number raised to the power 0, as we said initially, is always equals to 1. So we have that as 1. Okay, so number 4, we have the log of 0.01 base 10 equals minus 2. Same approach. So this simply means that 0.01 is the same as 1 on 100, which is normally you have to note. Okay, this is just something for you to note. 0.01 is the same as 1 on 100, which is 1 on 10 to the power 2, or the same as 10 to the power minus 2. Okay, so if I apply now the index form, we want to convert the log form now to the index form. What do you see? We simply have the log of what? 0.01 base 10 to be equals to minus 2. So in index form, we have it as 10 raised to the power minus 2 to be equals to 10 raised to the power minus 2, which is the same as 0.01. Okay, so that's it. So let's find the value of x in the following for better understanding. I believe at the end of this, we are going to better understand the notion of the relationship between indices and logarithms. Okay, so exercise 1. Given that we have the log of 32 base x to be equals to 5, how can we find the value of x? Okay, so converting this into index form, we have 32 equals to x raised to the power 5. Okay, but now what is 32? 32 is the same as 2 raised to the power 5. Okay, so 2 raised to the power 5 equals x raised to the power 5. Now observe and see that the powers are the same, and since the powers are the same, we simply have to equate the basis. Okay, that's the trick, and that's all. So it implies that our value of x equals to 2. Okay, question number 2. Given that we have the log of x raised to the power 5 base 5 equals to 0, expressing it in index form, we have x raised to the power 5 equals to x raised to the power 0. Now remember that any number raised to the power 0 is always equals to 1. So x raised to the power 5 equals to 1. Okay, and you have to know that for us to remove this 5 here, we simply have to include the fifth root to what we have on the other side of the equation. If we had 2 here, we have to introduce what? A square root. If we had 3, we have to introduce what? A cube root. But now we have 5, so we have to introduce the fifth root. The fifth root of 1, if you punch your calculator, you're going to have it as 1. Okay, so this implies the value of x is equal to. Question number 3. Given that we have a half raised to the power x equals to 8, how can we find the value of x? To solve this kind of problem, we have to begin by taking log on both sides. Okay, so this implies that we have log of a half raised to the power x equals to the log of 8. Okay, now remember the law of indices. This power always has to come down. Okay, this power has to come down, so we have x log a half equals to what? The log of 2 raised to the power 3, because 2 raised to the power 3 is the same as 8. And take note, this 3 will also have to come down in the next step. Okay, so this implies we have a log x log 2 raised to the power minus a half, because a half is the same as what? 2 raised to the power minus 1. Okay, so this 3 had to come down, so we have 3 log 2. I hope you understand the law we are using here. Okay, so now also this power minus 1 can also come down, so we have negative x log 2 to be equals to 3 log 2. Okay, and at this point we have to divide both sides by log 2 in order to make, negative log 2, so that we can make x the subject of the formula. So we divide both sides by negative log 2, and what do we see? We see that log 2 goes away with log 2 here. Also log 2 goes away with log 2 here, and the negative signs also go away. The negative sign here, this negative sign also cancels with this negative sign. This is what I mean. This negative sign here also goes away with this one. Okay, negative sign also goes away with that one, and we end up with our value of x to be equals to minus 3. Okay, question number 4. So if we have the log of x raised to the power 2 plus 6x plus 11 to the base 4 equals, we have the same approach. We convert this into index form, so we are going to have x squared plus 6x plus 11 equals to 4 raised to the power half. And you know that 4 raised to the power a half is the same as what? The square root of 4, which is 2. Okay, so we have x squared plus 6x plus 11 equals to the square root of 4, all of that raised to the power 1. Okay, which is the same as 2. Okay, so if you observe clearly, you're going to see that this is a quadratic equation. This is a quadratic equation per se, but we have to bring like them together. So 2 crosses this way, and since it's crossing, the sign has to change from positive to minus. So we have 11 minus 2 equals to 0. Okay, 11 minus 2 is simply 9. So we have x squared plus 6x plus 9 equals to 0. And this is exactly a quadratic equation that you can solve either by what? Using the formula method or the quadratic method. Either the formula method, the completing the square method, or the factorization method, even the graphical method, any method of your choice. Okay, so generally this is the general form of the quadratic equation: ax squared plus bx plus c equals to 0. And for this general form, to find the values of x, we simply use the formula x equals to negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Okay, so let's compare this equation with the one above. Let's compare these two equations. So if you compare keenly, you're going to see that the value of a is simply equals to 1, the value of b is 6, and the value of c is 9. Okay, if you compare these two equations, as you see this arrow, if you compare them, that's what you have. So now we just have to diligently substitute it in that formula method equation. This equation, we just have to substitute it in this equation here and simplify, and that's all. We get the value of x, or the values of x. So if we simplify that properly, we have negative 6 plus or minus the square root of 36 minus 36, which is 0. All of that divided by. So what do we have? What do we have? So we're going to have negative 6 plus or minus 0, the square root of minus 0 divided by 2. Okay, and the square root of 0 is simply 0. Okay, take note of that. So what do we have? So at this level, we have to separate our solutions, okay, because we have a symbol here referred to as plus or minus, so we have to take the plus form and we have to also take the minus form, okay. So first of all, our x will be equal to negative 6 plus 0 divided by 2, or negative 6 minus 6 divided by 2, okay. Oh, sorry, our first solution will be negative 6 plus 0 divided by 2, or negative 6 minus 0 divided by 2. We are using the plus or we use the minus, okay. So if we simplify that, negative 6 plus 0 divided by 2 is going to give us minus 3. And if we simplify negative 6 minus 6 divided, negative 6 minus 0, sorry, divided by 2, we're going to have x to be equals to minus 3. Okay, so they are double roots, okay. So number 4, given that we have 5 raised to the power 2x minus 26 into 5 raised to the power x plus 25 equals to 0. Please, this question is very trickish, and to solve this type of problems, in most cases, this kind of problems always lead us to quadratic equations. So you always begin by observing keenly. You see that here we have 5 raised to the power something, here we have 5 raised to the power something. That means there's a possibility for us to express this in the form 5 raised to the power something, all that squared, okay. And that's a lot of further powers that we can see here clearly, okay. So let's express this. This should be the same as 5 raised to the power 2, all of that raised to the power x. So when we multiply 2 times x, it gives us 2x. So that's why this is 5 raised to the power 2x, okay. Or you can write it as 5 raised to the power x, so that it resembles this other guy, all of that raised to the power 2. And that is really leading us directly into our quadratic equation, okay. So let's move on. So this is the same as 5 raised to the power x all that squared minus 26 into 5 raised to the power x plus 25 equals to 0, okay. So to solve this type of problem, let's begin by letting 5 raised to the power x to be equals to any constant. Let's call it m, okay. Let's call it m. So let's substitute it in the equation above. Anywhere we see 5 raised to the power x, we have to replace it with m, okay. So let's do that diligently. So we have m squared minus 26m plus 25 equals to 0, okay. So now this is a quadratic equation. So, and to solve a quadratic equation, we'll begin by, if we are using the method of factorization, here all of us use the method of factorization since we already used the formula method in the previous exercise. Let's use the factorization method here so as to move fast, okay. So to solve a quadratic equation by factorization, you have to ensure that when you have to look for two numbers, okay. That's two factors of AC. Our A here is 1, the value in front here, and our C here is 25, so 1 times 25. So we're looking for both positive and negative factors of 25, that when we add, it should give us what? When we sum them, it should give us negative 26, and also when we find the product, it should give us 25. Okay, when you multiply those two numbers, it should give us 25. Sorry, this is supposed to be 25. Okay, this is supposed to be 25. Negative 25. Sorry, the sum should be able to give us. Oh, sorry, it's okay. Negative 26. The sum should give us negative 26. Sorry. That's our value of B, okay. The sum should give us negative 26. Sorry for that mix up. The sum should give us, let me come again. To solve a quadratic equation of this form, we begin by looking for two numbers whose sum is going to give us the value of B, which is minus 26 in this case, and whose product will give us the value of AC, which is simply what? 1 times 25, okay. So our product, we are looking for two numbers whose sum is going to give us minus 26 and whose product is going to give us 25. So you start by writing all the factors of 25, all the factors of AC, which is 25, both positive and negative factors, okay. When you write them well, you start testing to see the ones that when you sum, it's going to give you minus 26, and when you add, it's going to give you, sorry, when you sum, yeah, it's going to give you minus 26, and when you multiply, it's going to give you 25. Okay, so if you observe keenly and do that properly, your factors are going to be minus 25 and minus 1. Because if you take minus 21 plus minus 1, your answer is going to be minus 26, which is correct. If you take minus 25 times minus 1, is going to give you what? 25. That's the product, which is correct. So those are the two numbers. So we substitute diligently. So we have m minus 25. Normally, it's supposed to be divided by 1. M minus 25 divided by 1 because of the coefficient of m squared here. All of that into m minus 1 divided by 1, which is the coefficient of m squared here, should be equals to 0. Okay, clear over that. So if we solve these two solutions, we are going to have the values of m. Okay, so m minus 25 equals to 0. simply implies sign 25, the other side the sign changes to become positive, so implies m equals to 25. Okay, also m minus 1 is equals to 0, so if we send minus 1 the other side becomes plus 1, so m equals to plus 1. Okay, so that's it. But now we are not looking for the values of m, we are looking for the value of x. So but we know that we had made an assumption above that 5 raised to the power x is equals to m. Okay, so 5 raised to the power x, let's begin with the first value of m, which was 25. The first value of m we had was 25, so let's substitute it here. So 5 raised to the power x equals 25. Now to solve this type of problems, we know that we have to take logarithms on both sides. Okay, so log of 5 raised to the power x should be equals to log of 25. Okay, you know that 5 raised to the power x is the same as what? Sorry, the log of 5 raised to the power x is the same as x log 5, right? And 25 is the same as 5 raised to the power 2. So log 25 is the same as what? 2 log 5. Okay, take note of that. So we have x log 5 equals to log 225, and this implies that we have to take to make x the subject, we divide both sides of the equation by log 5, and we do that diligently and simplify properly, as I've explained already. You see that at this point log 5 cancels with log 5, and our answer is 2. That's the first value of x. This is the first value of x, 2. Okay, also we also know that 5 raised to the power x was equals to 1, because m2, another value of m was 1, so 5 raised to the power x equals to 1. And to that effect, we have to know that any number raised to the power 0 is always equals to 1. So I can express this to the base of 5 by simply writing it as 5 raised to the power 0. Okay, and anything raised to the power 0 is always equals to 1. Now if you observe here keenly, you're going to see that the bases are the same, so we equate the powers. So another value of x is equals to 0. That means we have two values of x equals to 0 and x also equal to 2. Okay, so that's the solution. So we have come to the end of this lesson, and I just want to thank you all for watching, and please, I would like you all to kindly subscribe to our YouTube channel by clicking on the subscription button, so that anytime we upload a new video, you'll be updated. Okay, thank you so much. The only way you can support S-CUPREC is simply by subscribing to our YouTube channel, and also please like, okay, share to your friends, and also please comment. And I also want to say that please, if you find any difficulties, you can always place your difficulties or questions or worries in the comment section so that we attend to them. Thank you so much.